Hello and welcome back to another How to Math. Today we'll be going over properties of quadratic functions. So this would be the direction of opening, the vertex of the parabola, and the equation of the axis of symmetry. So first we'll use this example, y equals 2 bracket x plus 4 squared minus 7. So this is in vertex form, so we can get the coordinates of the vertex right away. So the vertex is x plus 4, so we use the opposite sign. So the vertex is -4, comma, -7. And then we have the vertical stretch by a factor of 2. So when we graph this, actually, we can do something like this, have this. So we have the vertex at -7, and then -4, so around here. And this is opening up because the a value is positive, so it's opening up. And actually the equation of the axis of symmetry is just the x value of the vertex. So the axis of symmetry, I'll put sim for short, is x equals -4. So we can actually just so it would be something like this. Oh, that was terrible. Okay, well, something like this and this. Yeah, so the axis of symmetry is at x equals -4. Right, so we'll move on to another example. This one will be in root form. So that's 3 bracket x minus 2 means x plus 6. So we have the roots of the parabola, excuse me. So the vertex will actually be in between these. So we can actually graph this to help us first. So we have the x-intercept at 2, and another one at -6. So -6. Now the in between these two, so we can actually add these. So that'll be. Sorry, we can actually. Yeah. So we just -6 minus 2. That'll be -8. So there's 8 in between. Divided by 2, that'll be 4. So -6 plus 4, that'll be -2. So around here. So that'll be the axis of symmetry, because it is the x value of the vertex of symmetry is x equals -2. The vertex is -2 comma something. The way that we can figure out the y value is if we plug in -2 into here. So y equals 3, bracket -2 minus 2, -2 plus 6. So we have -4, y equals 3 times -4, and then times 4, so that'll be -16 times 3, so y equals 3 times -16, so that'll be -30, that'll be -48. Y equals -48. -48. All the way down here. -48 down here, and the a value is positive, so it's opening up. And it is vertically stretched by a factor of 3. So from here, now those are the properties of two quadratic functions. Now we can move on to a word problem. So we'll just clear this first. So we can move on to a word problem. Let's just say a ball is thrown out of a window. A ball thrown out of a window has a trajectory modeled by the quadratic function h of t equals negative 5t squared plus 15t plus 20, where h of t is the height of the ball, represents height of ball at t seconds. This is in meters. So the ball in meters at t seconds. So we can actually graph this first. So we can actually factor this. So h of t equals, so we can pull out negative 5, that'll be t squared minus 3t minus 4. And then we can use the crisscross method, which will be t, do minus 4, and t plus 1. Because minus 4 times 1 is negative 4, but when you add them, it's negative 3. So we have actually, we have the x-intercepts. So there's one at negative 1 over here. There's also, well, that's like out of the domain. So we have 4. And then, yeah, so what we are actually looking for is how high up the window is. That is the first, so how high up the window is, let's say that's A. So that would actually be the y-intercept, because the window is when t is 0. So we can put h of 0 equals so negative 5 times negative 4 times 1, which equals 20 meters. So the height of the window is 20 meters. So we can actually put that here, 20. And then, actually I should probably put that a bit lower, because that is not the max height actually. Put that at 20. Now the next question is what is the ball's max height? To be able to do this, we'd have to find the vertex. So we have negative 4 and negative 1, so we have, so 4 and negative 1, so 4 minus negative 1, that'll be 5, divided by 2, that'll be 2.5, so it'll be 2 and then 1.5, so it'll be around here. So 1.5 will be the middle, and then we have to find the y value at 1.5. So h of 1.5 equals negative 5, 1.5 minus 4, 1.5 plus 1 equals negative 5 times negative 2.5 and then 2.5. This equals that would equal negative 5 times negative 6.25, which equals 31.25 meters. We have 31.25. That'll be right over here. And we have over here. And there we have the graph of this function. This is the ball's trajectory. And the last question will be, when will the ball hit the ground? We actually calculated that because we have the x-intercepts. So the ball will hit the ground when t equals 4 seconds. So there we have it. Those are properties of quadratic functions. I'll see you in the next video.